Hi, we're excited to share Trove with you, a flexible and easy-to-use toolkit for dense retrieval, which for the first time offers efficient and powerful data management features. Here's an example workflow for Trove. We'll start by defining several configurations, which we use to build our dataset, collator, and model components. Then, we create a trainer or evaluator object that executes the main task. Let's start by installing and importing Trove. Then we'll define a model configuration, which we use to build a model. Trove already implements the dual encoder retrieval logic in the by encoder retriever class, supporting various pooling operations, LoRa adapters, and more. For maximum flexibility, we also provide easy abstractions for users to create custom encoders, loss functions, and retrieval logic. And you can check out our package documentation for all the different ways to customize Trove models. Now let's create a dataset. We'll directly use Hugging Face Hub URIs, which Trove automatically downloads. Unlike other frameworks, Trove supports preprocessing and combining multiple data sources on the fly. Here's why that's important. To experiment with different data configurations, previous frameworks require manually creating and maintaining new data files for every configuration. Trove's new materialized QREL container offers flexible data processing options, enabling us to quickly experiment with different data configurations by simply changing config options. Let's see this in action. First, we build a config for the synthetic data, which has labels from 0 to 3. Next, we create a config for the original MS Marco files, but we ask Trove to only select documents with labels greater than or equal to 1, which are positives, and we'll assign them all a label of 3. Similarly, we create a config that selects 2 mined hard negatives for each query and assigns them the proper label. Let's combine them into our dataset object and also create our collator object. To create our trainer, we define our retrieval training arguments and then the main trainer object. Evaluation is very similar to training. We just create the evaluation arguments and instantiate the evaluator object, which we can use for both evaluation and hard negative mining. Trove supports multi-GPU and multi-node training and evaluation using a distributed launcher like Accelerate. Unlike other frameworks, Trove's multi-node evaluation works out of the box, without extra code. Finally, we have well-documented Trove, and we provide detailed guides for training and evaluation and how to customize each workflow.